Hello, my name is Raef Eagan, and this is my flight dynamics project that will demonstrate the yawing moment induced by a pitch rate for a propeller aircraft. This is my apparatus here. It's made using a block of wood erector set for the upper structure, and the actual aircraft is made using foamular, a battery, and an electric motor. So how does it work? Well, using equations learned in our flight dynamics class, one can calculate the actual yaw angle that it will go to when a pitch rate is induced. So the constants important in these equations are the moment of inertia of the propeller, modeled here as a disk, the angular velocity of the propeller, the pitch rate, and also the spring constants of these rubber bands here. I will now demonstrate its performance. So look at the propeller spinning there. And you can see as I induce a pitch rate, the yawing moment. As I pitch up, you can see it move to the right, and I will move back to its original position. And as you can see, it's perfectly balanced to its center of gravity, so it's straight on. And as I pitch down, it induces a moment to the left. So now that we've demonstrated the project performance, we can actually calculate the yaw angle of the aircraft. So from our experimental data and video, you can find that the deflection of the aircraft is roughly 18 degrees. Now, to calculate the ideal deflection comes down to, this is our equation, theta ideal equals the angular velocity times the moment of inertia times the pitch rate divided by the spring constant of our rubber bands. So to calculate the angular velocity, we used the high-speed camera and counted the revolutions in 1 second, and then convert that to radians per second. Next, the moment of inertia of a disk is mr squared over 2. The mass of my disk was 1 gram, and the moment of inertia comes out there. Here we have the pitch rate. From our video, we can see it moves about 90 degrees in 5/6 of a second, or pi over 2 radians, so that's 3 pi over 5 radians per second. And the spring constant using a mass and a deflection, we can find that. And finally, our equation here for theta ideal. Calculate all that out in our handy dandy calculator, and we get roughly 16.39 degrees with an experimental angle of 18 degrees. So pretty close, works pretty well. I'm very happy with it.